We're at the group 5 with members Aurimas, Alex, Paul, and Juan. And in this video, we'll talk about our semester project. We'll start with introduction, then move on to requirements, architecture. Then we'll talk about the features implemented and also discuss the future of the project. And finally, we'll end our presentation with a summary. My name is Alex, and I will talk about the introduction and requirements. The tourism industry is a huge industry, and there are not a lot of players in the digital map industry. One of the most used application is Google Maps that has over 1 billion active monthly users, 87% of which only use the app for directions. This shows the need of an app that lets one explore new places. Based on that, a lot of questions came up, a lot of issues that needed to be addressed. Therefore, this was our problem statement. With all this information, we stated the purpose of the project, which is to bring unknown places to the spotlight and create requirements, sort them by priority, set what the actors of the system would be able to do. Then we started creating the architecture. Our system has 3 tiers: client tier, logic tier, which handles logic for regular users and moderator users, data tier, which handles persistence. The logic tier is distributed such that there's one moderator server, which only moderators have access to the functionality exposed by this server. Only one is deployed. And many user servers, all users have access to this server. Multiple of these can be deployed in different locations. And the system is also heterogeneous. Client tier and data tier I've written in C# and .NET framework. The client uses Blazor, data server uses Entity framework to use the database. JavaScript was used for Mapbox. Logic tier is written in Java. It uses Spring to expose a REST API, uses RabbitMQ for querying tasks regarding newly added data. Next information about the architecture of the system will be presented by Juan.
Thank you, Alex. My name is Juan, and now we're going to talk about the communication of this architecture. And in this 3-tier architecture, there are different communications going on. First, between the first and the second tier, the communication is made using a REST web API. The first tier consumes the REST API that the second tier exposes using the Spring framework. Also, the client can subscribe to newly added places live that the API exposes via UDP sockets. And secondly, between the second and the third tier, they communicate via TCP sockets using a simple protocol. And it is worth to mention that these sockets are used in different ports in parallel. This way, the communication relation to different information is going to be done through a specific socket. Now, about the web services. The web services that this system uses, that this system consumes, are 2, the Mapbox and the REST web API. We use the Mapbox API in the tier 1 for presenting the map in a vector format. And this API allowed us to ping markers throughout the map in certain locations for creating then the places in the system. And we use the REST web API for the communication between the tier 1 and the tier 2 for sending and receiving data between them, using the Spring MVC for mapping HTTP requests. Also, the REST web API allowed the client to subscribe for live updates, as mentioned before. Following the web services, this system also exposes one API, which is the exposed by the second tier, and is the functionality for regular users and moderators through REST API calls. Now, following the protocol for the sockets part, the current protocol for the system, it's a 3-step protocol. in which the client first sends a command to the server, which could be, for example, depending on the case, adding a place or getting a place, add place, get places. And the second step the client would send this data optionally, depending if it's needed or not, in a JSON object, if it represents an object or plain text. And then the third step would be the server replying with the data if it's needed also. Now, Aurimas is going to talk about the security.
Thank you, Juan. Implementing the secure communication between tiers was not part of a semester project, though it was a requirement to identify the risks and possible attacks. To the right, you can see the risk assessment table of the system. It's also documented in more detail in the project report. The goal is to examine which attacks can be made, both active and passive attacks, in order to preserve the confidentiality, integrity, and availability of the system. Passive attacks are mainly done by analyzing the traffic and reading message content, which would uncover the communication protocols and release the format of the messages. And they could be used for creating active attacks. Active attacks are done in different ways: masquerade, replay, modification, or denial of service. These attacks could affect the functionality of the system and the data stored by it. To prevent all this, it would be a great idea to use HTTPS server in the system, since it implements SSL or TLS. Also, deploying multiple servers for load balancing, backups of data could offer more ways of recovering from attacks. Moving to GUI. For creating the graphical user interface, ASP.NET framework called Blazor was used. We chose Blazor over JavaFX because it's easier to implement and is more powerful tool compared to the latter. For example, Razor pages and components allow integration of HTML and C# code. Dependency injections reduce memory needed by allowing of calling the model to make use of the methods without initializing the object. Easier layout of the page by using Bootstrap, which is also in the framework. Also, other Blazor components were used for implementing form validation and external components for rating systems or displaying error messages. Also, I need to mention that the Razor components can be reused multiple times on different pages, which helps in case of the need of changing the implementation of the component. For example, if there were changes to be made, you would only need to change the component once and all other pages that use the component would update. In our opinion, these and other features helped us in reducing the time required for developing the visual representation of Tier 1. We compared this to the experience we had in previous semesters. Now moving on to Paul, who will talk about the future of the project and summarize.
Thank you. I'm Paul, and there are multiple things that we can do to improve this project. Some of them are improving the REST API to be more RESTful, improving the socket protocol, securing the connections, implementing the features that we didn't manage to implement, which are mentioned in the requirements, and also some other improvements. First, let's talk about the REST API. There are multiple ways that we can make this more RESTful. The two main ones are making use of the HTTP status code, so the client would know what's happening behind the scenes, and also better URI mappings, as some of the current ones are not very RESTful. To implement this without causing other clients that are using our API to stop working, we can create new REST controllers, which are going to be based on a URI which is prepended by v2, therefore publishing the second version of the API. Another improvement is the protocol for sockets. Right now it is quite simple, and it doesn't allow for multitasking on the same socket. A new one would consist of a message, which would contain objects and commands, knowledge codes, and status codes. It is similar to the functionality of HTTP and TCP in general, and it will also allow for multitasking on the same socket, since the knowledge codes will match the different tasks. Another improvement for the socket would be to secure the channels using TLS. To summarize, we have created a system that is distributed. It is organized in 3 tiers, and one of the tiers is also distributed by itself by allowing the deployment of multiple servers throughout the world. It is also a heterogeneous system by combining C# and Java split across multiple components of the system. We are consuming and exposing our own REST API, and we're also consuming a map API that is shown on the client. We actually have 2 TCP protocols designed, but we're using one of them. The system has a graphical user interface. We have considered the security risk of the project, and we have some room for improvement. That's it from us. Thank you for watching, and have a nice day.